Hi, it's Moser with quick tutorial on molar mass and how you use that to do basic compositional stoichiometry. You've done stoichiometry before! This is conversions. Oh, yeah. Remember your GMA? Grams to moles to atoms and backwards? Same thing here, except that atoms is really now formula units. Okay, great. So grams to moles to formula units to moles to grams. But GMA is still a great way to remember that you have to go through moles to get from grams to formula units or formula units to grams. Let's do some practice. So the skills that you have to have well established to do these are how to find molar mass given a chemical formula. So if we wanted to know how many moles there were in 100 grams of sodium chloride, well, let's just set that up. I'm going to write down my formula, and I'm going to do my little shorthand here of listing my elements, and I'm going to put in their molar masses. And since there's only one of each atom, in this case actually ion, we multiply by 1, we add them up, and we find that there are 58.44 grams in a single mole of sodium chloride. That's going to become our conversion factor. Now we will need to do a factor label for that. Remember that factor labels always start with your given in the first box, and our given here is 100.0 grams of sodium chloride. Now, we want to know how many moles of sodium chloride that is. So we need to have units here and here cancel. So we know we're going to be using grams of sodium chloride, and we know that we want to have units here that we're going to end up in. So that will be moles of sodium chloride. Remember when doing conversions that unless it's your given, you never put any number except 1 in front of moles. And we just found how many grams of sodium chloride there are in a single mole. Okay, you've done the math, and what we get is a raw answer of 1.71156, blah, blah, blah. It goes on and on and on. How many sig figs do we have to work with? Well, remember that our sig figs are going to be governed by our given, and that had 4 sig figs in it. So our final answer is going to end there. We have 1.711 moles of sodium chloride. Okay, let's do the next example. We want to know how many molecules there are in 250 grams of C6H12O6. That's glucose, in case you forgot. So the first thing we have to do is find the molar mass of glucose. Okay, I've gone ahead and figured out the formula mass of glucose. I multiplied the molar mass of each individual element by the number of atoms of that element, and then I added all of those together. So I get a total of 180.18 grams per mole of glucose. Now, let's get to the problem at hand. When I'm setting up a factor label, I always start with my given, and in this case my given was 250.0 grams C6H12O6. And I want to know how many molecules there are there. I'm going to need more space. When I pull out my handy little GMA chart, what this tells me is that if I am going from grams to molecules, I'm going to have to do a 2-step factor label. So I put my given in my first box with grams, and I know that I want my units and my chemical that are down here to cancel. So I know that I'm going to use grams of C6H12O6 in that bottom next box. And I know that since I have to go through moles, I'll have moles of the same up top. Okay, I also know that I never put any number except 1 in front of moles unless it's my given, and that I found the mass in grams of a single mole of glucose. 180.18 grams of glucose is equal to 1 mole of glucose. Now, I know that I want to end up in molecules of glucose. Be careful, don't write that as MOL or you will mix them up, honestly. So I'm going to make sure that my units and chemical in this box here cancel. So I've got moles of glucose, and I need the number for how many molecules of glucose there are in a single mole. Remember that there are 6.022 times 10 to the 24th pieces of anything in a mole of that thing. So, while there are 6.022 times 10 to the 24th atoms in a mole of a particular element, there are also 6.022 times 10 to the 24 molecules in 23rd. Good heavens, Moser. 23rd in an atom, or, I'm sorry, 6.022 times 10 to the 23rd molecules in a mole of glucose. Okay, do we have everything set? Do all of our units cancel where we want? Grams of moles of glucose. We're left with molecules of glucose, and that's right where we want to be. So let's do the math. I've gone ahead and pulled out the numbers to make my math problem, and then taking all the numbers across the top, multiplying them, all the numbers across the bottom, multiplying them, and then dividing the top by the bottom. Multiplying that whole thing by the power of 10 that I found, and nothing else was raised to a power of 10, so it's just 10 to the 23rd. Okay, what that leaves me with is 8.3555533, on and on and on, times 10 to the 23rd molecules of glucose, C6H12O6. How many sig figs do I have? 4. So 1, 2, 3, 4. I can keep that. My final answer will be 8.356 times 10 to the 23rd molecules of glucose. We'll do one more together, and then you practice on your own. Okay, we're asking what's the mass in grams of 8.0 times 10 to the 45th molecules of CH4OH. Well, again, first we're going to have to know the molar mass. We know that. So I'm going to list everything in CH4OH. There's a bit of a trick here. There are only 3 elements. 12.01, 1.01, 16.00. The question is, how many of everything is there? Well, it's easy to see that there's only 1 carbon, but how many hydrogens are there? We have 4 here, and we have 1 there, so there are actually 5 hydrogens. And then there's only 1 oxygen. Let's do our math. Okay, we get a molar mass for this compound of 33.06 grams per mole. Now, what we wanted to know was what the mass in grams of 8.0 times 10 to the 45th molecules of the stuff are. So if we remember our GMA, here we're going from atoms, molecules, formula units, through moles, and on to grams. The first thing we are aware of is that the units and chemical here have to match here so that they'll cancel. So let's set that up. Fantastic. And we know that to go from atoms or molecules or formula units to grams, we're going to have to go through moles. So we know that this is going to be moles of CH4OH. Okay, well, do we have a conversion factor between molecules and moles? Yes, we do. We also know that the only number we ever put in front of moles, unless it's our given, is a 1. So how many molecules of anything in a mole of that thing? 6.022 times 10 to the 23rd molecules. That's how many. All right, our last step. We know that we need the units in this top center to cancel with what is on the bottom in the last space. And we know that we want to end up in grams of CH4OH. So we know that that's going to be the units and chemical that occupies our final top spot. Grams CH4OH. Do we have a conversion factor? You bet we do. 33.06 grams of CH4OH per 1 mole of CH4OH. Alright, I'm going to pull out the numbers to set up the problem. Alright, I have 8 times 1 times 33.06 divided by 6.02 times 1. The whole mass times 10 to the 45 which I'm getting from here, minus 23. Because I'm dividing anything on the top by anything on the bottom, any exponent on the bottom will be subtracted from any exponent on the top. Okay, the raw answer I get is 43.9189638, blah blah blah, on, times 10 to the 22nd grams of CH4OH. By the way, that's a crazy mass, and normally we don't see numbers that big as anything of 10 to the 45th in a problem. Whoever wrote this problem, geez Louise. How many sig figs do we have? Well, we came into this with actually only 2 sig figs. So this is going to end up being 4.4. Oh, wait. We have to do something, don't we? We have to move the decimal because this is not proper scientific notation. Okay, we know that if we were going to fluff this number out, we'd be going this way, and it would be getting smaller. So 21, 20, 19. As we come back the other way, this exponent will be 1 larger than it currently is. So this would be 4.4 times 10 to the 23rd grams of CH4OH. All right, now you know how to do some basic compositional stoichiometry. You know what comes next. Practice, then FIP.